Hi, my name is Micah,
And my name is Rushti.
and our project is called ThirdSpace, an AI-driven scalable dating app. We have four main project goals. We want to design an app that builds inclusive connections, uses AI-driven matching, promotes safety first, and is scalable. We use 7 different data scale center software components. For message encoding, we use JWT tokenization to hash our passwords. We use Python Pickle to serialize driver's license images. For API interfaces, we use PyTesseract for OCR, Hugging Face for calculating match scores, SendGrid for sending emails to users. For message queues, we use Redis to queue tasks from a REST server to worker servers. For databases, we use NoSQL to store dynamic and diverse data structures. For key value stores, we use Firestore to store user profiles, matches, and likes. For virtual machines and containers, we use GKE to deploy and manage the app in a cluster on the cloud. We use GCE VM to start, delete, and interact with the cluster. And we use Docker containers to deploy the REST server in each of the 3 types of worker servers. For storage services, we use MinIO to store driver's license images. These are our software components, and these are our hardware components. This is our first architecture diagram. It shows how all the external APIs interact with our app. So we have the user that uses Postman to send API requests to the app. The app is going to be storing user profiles in Firestore, as well as driver's license images in MinIO. We use Google Python Tesseract to extract text from the driver's license images to verify user identity. And then we use SendGrid to deliver emails to users after they've received a like. This is our second architecture diagram. So again, this is showing that users use Postman to send API request to our REST server. This request passes through a gateway, which is monitored by a traffic-based horizontal pod autoscaler. The server queues work to each of the 3 workers via a Redis queue. And there are 3 different worker servers, and they each have their own Redis queue. The register user worker server, the get matches worker server, and the like users worker server. Each of these worker servers have their own CPU usage based horizontal pod autoscaler. And the entire Kubernetes cluster uses a cluster autoscaler. So combining the pod autoscaler and the cluster autoscaler, you have end-to-end scalability. And then for external services, storage, we have MinIO that the worker 1 server uses for the driver's license, and then Firestore is used by all 3 workers to set and store data. For software hardware interaction, we have 3 major workflows. This will be shown in the demo later. This is our system overview and how we handle our workload. So we built a scalable backend that uses Redis queuing, Firestore, and is deployed on a GKE cluster for asynchronous distributed computing. We have multiple scaling mechanisms, including a traffic-based horizontal pod autoscaler, which creates additional REST server pods to handle increased traffic, a CPU usage-based HPA that creates additional worker server pods to handle increased queued tasking. We have a load balancer via a gateway, which distributes user requests evenly between REST server pods. We use Redis to queue tasks to workers, and we use Firestore to handle high concurrency data storage. Our major bottlenecks are overloading either the horizontal pod autoscaler or the cluster autoscaler by sending too many requests over too short of an amount of time and exceeding the capacities for those autoscalers, and Firestore latency under peak load. For debugging and testing, our primary debugging tools are Postman for API testing, the Python logging module for logging, and a kube control to interact with our cluster. And then for testing mechanisms, we use end-to-end testing using Postman for different workflows. We use OCR verification on a diverse set of driver's license samples, and we are continuously monitoring logs for Redis queue. And now it's showtime.
Now let's see how ThirdSpace works. Our application is hosted on this IP address, and we have saved it in a variable called prod, and we'll be using this variable in all other APIs. This is our home page, and after hitting this API, we get the response saying, "Welcome to ThirdSpace." Next step is registering a new user. Now, I've already filled out name, email, password, and driver license for verification of the user. And if we hit this API, it gives the response saying registering user Murray, and this task is queued in Redis. Next step is to log in as Marie. So if the OCR verification is successful, this user should be able to log in successfully. Otherwise, it will say user not found. Uh, let's hit this API. We got a token generated, and I'll quickly update it in all other APIs so that we'll be able to hit all the APIs for this person. This is the JWT token that we are using. Now, next step is to update the profile for this user. So we have already updated authorization token here, and in the body we are sending out the name, email, and preferences for this user, which has gender, age range, and the location. If we hit this API, the profile will be successfully updated in Firestore. Next step is to run the Hugging Face algorithm using this matches to API, and it gives out a response saying finding top matches for Muddy. Next step is to get to fetch these matches from Firestore, and this will give out a list in descending order with the descending order score. So if you can see the first user in the list is Brenda with a score of 100. Then we have Alexander with score of 1, and then Swagat Kumar with a score of 0. So let's say that Marie likes Brenda. In the next step, we need to update the body with the target user as Brenda, and then authorization token is already updated and will send the response is user Marie is liking user Brenda, and Brenda should get an email saying she has a like. Let's see. This is the latest email she got at 6:20 minutes ago. So she got a notification saying, "Hello Brenda, Marie likes your profile." We'll go back again, and this time we will log in as Brenda and see how it works. So Brenda is already registered. We'll log in as Brenda here. We'll get the token again. I will update it in the matches API, and then get matches API, and then the likes API. We'll go back to matches. This will, I already hit this API, so it has queued this task where it's finding matches for Brenda. And then this API will fetch us the top choices for Brenda. We can see Marie has a score of 100 here, and then Alexander has 1, Swagat Kumar has 0. So now Brenda wants to like Marie. In the next step, we will use this as the target user here and hit this API. We will get user Brenda is liking user Marie, and in this case, since it's a mutual like, since Marie also liked Brenda in the last step, they both should receive an email saying, "Congrats, it's a mutual like, and here are the email IDs to connect with each other." So this is the first email, and this is for Marie. Marie should also have gotten a mutual like, and these are the contact details.